Hello, welcome to GraphMapper tutorial at the University of Queensland School of Architecture. Christina here. Today's exercise is a parametric object using GraphMapper tool, and we'll start the same. We started with similar object by introducing a point in rhinoceros and defining it in grasshopper. Now we need to make them see each other. Okay, now it's done. And let's create a polygon from here. Polygon, so it's curve primitive polygon, and we'll use our created point as the plane for this polygon. Then we will define its radius and the number of segments. Let's say whatever we want, probably 5. Radius, okay, I'm pretty much satisfied with that. Let's switch it to this curve, so it's gonna be a new one. We don't have to do that, but I like making it more in order by introducing this ingredient. It doesn't have to be here. Next component we're using, as we did with the previous exercise with the similar object, is move. Here it is, we're moving. Similar to what we did previously, we'll need to specify a vector of movement. I want it to move up, but I don't want it just to move once. I want it to move in series. So we'll have to introduce a series here. Then step. Let's put some step. Yep, I'm good with that. And the number of levels, which would refer to number of floors if it was a building or another built object with evenly located floors. Next component will be slightly differently operated. I enjoy putting it with the curve. Rotate. Now we will rotate what we got from here. Transformation. Rotate. Here it is. Now it rotates around this point. This is not what we want. We'll need to go to surface panel and find the center of each element. So each floor will rotate around this center of each element. Now it's here. Okay. Last thing we need to put as input into this component is the angle of rotation. Last time we used radians. Let's go with degrees this time. Let's change it to degrees. It will require another operation, but we'll get there. Then we'll take a new component called GraphMapper. We can find it easily just typing it like that, or it's located in params. Input GraphMapper if you'd like, and we can choose what kind of GraphMapper we want. I will go with the Bezier this time. You can go with anything you like. Then let's see if we can plug it to anywhere. Nope, nothing happens yet. Even if you play with it, nothing happens. Why? It needs to be introduced in here with a numerical number, still, sorry, let's do it like this. Still nothing really, because it has to be, let's say, reparametrized, and we will do that using range element. It's located, oh my god, where is it? Let's just call it range. So we'll create a range of numbers that are extracted from here to here, and here we go. Now it's more interesting. Something happened, but we don't really see it yet. Here, as this node has basically not really 12 elements, but 13, which is like +1, and it's not what we want from it. We will have to specify an expression here, and this expression will be x minus 1, because it takes not the intervals, but the intervals, and we want it the other way around, so we'll need to introduce some extra math here. Still can't really see anything, and that's not exactly what we want. Why don't we see anything? Probably. Let's find out why. Okay, we can't see anything because the range on the output from the GraphMapper is from 0 to 1, and these are the values that are transferred to angle, specified as the angle here. And it's not what we want because it's too small, we can't really see it. We see something happened, but we can't really appreciate it or visualize it. That's why we'll need an extra mathematical operation. And we will use multiplication and multiply the values that come from here. Let's introduce some number, maybe 70. Let's see if 70 will work for us. Yes, it does. 70 worked perfectly well for us. And now our values are larger and enough for us to see. So after that, you can play with your rotation, and it will be uneven, and it will be defined by the graph here. So basically each value of rotation is located on the intersection of graph lines here. So by changing it, you change the rotation angle. Really fun thing to play with. Next element we'll be using is scale. We already did it last time. This time not really much changes. Same geometry taken from here. We'll need to use same values coming from centroid here. Button. Why not? Oh, with shift, sorry. Yeah, now it works. And again, we can use GraphMapper to specify the evenness, let's say, of our scaling. GraphMapper here. So that's our factor will be defined by GraphMapper. Also, we'll use this remap tool. Okay, very interesting. Now we should specify what type of graph we want. Let's go with this one. Could be actually whatever else you like. It's all pretty much up to you. And here's what it does. Actually, it's basically what I wanted, but no, it's pretty much okay actually. Can be like that, because here this value is 0, which means this graph will scale your object. Let's just hide all the rest that we don't need. And I think we should already see how it all goes and loft it. Loft operation is probably something you're familiar with from Rhinoceros or from basically any other 3D creating software you've been using so far, like that maybe even. And let's use custom preview component to make it some funny color. Any color is funnier than this pink. Okay. Now you can see how we can easily control this parameter by just dragging the point on graph and see how it's changing our geometry in real time in Rhinoceros. Or we could just use another type of graph and go with Bezier, but it will be a little bit like that. And again, it's all red because it requires different kind of data input. See, if this beginning of the graph is on 0, then it will mean that the beginning of our scaling is in 0, which is not really possible to scale. Scale factor can be 0. So we'll have to slightly move it. And here we go. We have our results. Controlled easily by just dragging the slider, or not the slider but the GraphMapper tool, or the slider if you'd like, also would work actually. I hope you enjoyed it, and welcome to Grasshopper.